Today we are going to complete lesson 7.3, solving equations using multiplication or division. This is on page 208 of your Big Ideas textbook. Our purpose today is going to be to use inverse operations to solve multiplication and division equations. So essentially, we're going to do the same thing we did yesterday. The only difference is, instead of it being addition and subtraction that we're working with, it will be multiplication and division. Let's review. I want you to think to yourself, what does the word inverse mean? This is what we talked about yesterday. Okay, if you remember, inverse operations are operations that are the opposite. Essentially, they undo each other. We've already talked that addition and subtraction are inverse operations. So today we're going to be talking about multiplication and division. Multiplication and division are also inverse operations. They basically undo each other. So with the multiplication property of equality, what this means is when you multiply each side of an equation by the same non-zero number, and I want to highlight this. This is really important. Non-zero number. The two sides remain equal. The reason, obviously, that it has to be a non-zero number is anytime you multiply a number by 0, the answer is 0. So when we are multiplying or dividing, we have to have a number that is not 0 that we're doing this with. So on our number side example, I have 8/4 equals 2. Now, we've talked multiple times about how a fraction bar simply means divided by. So 8/4 equals 2 means 8 divided by 4 equals 2. Now, the way that we get rid of the division or the dividing by 4 is to multiply both sides by 4. Think about 4 is the same as 4 over 1. So I can cross cancel here, which gets rid of the 4's, and then I just have 8 over 1 on this side. Over here, 1 is already on the bottom. 2 times 4 is 8. So again, I have 8 over 1. And 8 over 1 is the same as 8, so 8 equals 8. The same is true for algebra. So if we take a look at this problem, x divided by 4 equals 2, or x/4 equals 2. Do the same thing. Multiply by 4 on each side. Obviously, I can cancel out. And on this side, I'm going to have x times 1, which means x, and 1 times 1 on the bottom is just 1. So I have x equals 8. We are now going to talk about the multiplicative inverse property. What this means is the product of a non-zero number, n, and its reciprocal, 1 over n, is 1. Now, reciprocal just means that anytime you've got a whole number, for example, I'll use the number 8. If I wanted to find the reciprocal of 8, the whole number is 8 over 1, because any number over 1 equals itself. We have to flip it over, and that means I have 1/8. So the product of a non-zero number n and its reciprocal is 1. So 5 times 1/5 is going to obviously equal 1. N equals 1 over n. N times 1 over n is going to equal 1 over n times n. So as long as you're not talking about 0, this multiplicative inverse property will always work. Okay, let's take a look at an example. I have solve w/4 equals 12. Remember, fraction bar just means divide. So w divided by 4 times 4 is going to be equal to 12 times 4. Notice, on each side, I'm just adding times 4. The 4's on the one side cancel out, so I'm left with just w. And 12 times 4 on the right equals 48. The solution is W equals 48. Now, if I go back to my original problem, W fourths equals 12, and I substitute 48, that means 48 divided by 4 equals 12, and that is true. There is also the check right over here. Okay, now we're going to do the exact same idea, except it's going to be division. The division property of equality says that when you divide each side of an equation by the same non-zero number, remember we always have to be talking about a non-zero number, the two sides remain equal. So for my numbers side, I have 8 times 4 equals 32. Whoops, sorry about that. Let me grab the highlighter. Okay, so over here I have 8 times 4 equals 32. That means what I now have to do to cancel out that the multiply by 4, I'm going to divide by 4. 8 times 4 divided by 4 equals 8. The multiply by 4 and divide by 4 right here cancel each other out. So these two cancel each other out. And then 32 divided by 4 equals 8. So on both sides of my equation, I'm left with 8. When I look at this same idea, just with an algebra problem, 4x equals 32. Well, if I'm multiplying, the opposite of multiply is divide. So you can see down below, it says 4x divided by 4, 32 divided by 4. Fraction bar just means divide. 4 divided by 4 leaves me with just x on the left. 32 divided by 4 leaves me with 8 on the right. Now, I'm going to go back to my original problem. 4x equals 32. If I substitute 8 for the x, I'm going to have 4 times 8 equals 32. And we know that answer is correct.